Welcome to our lesson on the evidence for the continental drift theory. In this session, we'll dive into the groundbreaking ideas proposed by Alfred Wegener that revolutionized our understanding of Earth's geological history. The continental drift theory suggests that continents have not always been in their current locations, but have moved across the Earth's surface over millions of years. This theory, which initially faced skepticism, is now supported by various lines of compelling evidence. Key evidence supporting continental drift. Fit of the continents. The remarkable fit of the coastlines of South America and Africa suggests that these continents were once joined. This jigsaw puzzle-like fit was one of the first clues that led scientists to consider the possibility of continental drift. Fossil evidence. Identical fossils of ancient plants and animals have been found on continents now separated by vast oceans. For example, fossils of the Mesosaurus, a freshwater reptile, have been discovered in both South America and Africa, indicating these continents were once connected. Geological structures. Similar rock formations and mountain ranges are found on continents that are now far apart. For instance, the Appalachian Mountains in North America are geologically similar to mountain ranges in Scotland and Scandinavia, suggesting these regions were once part of the same landmass. Paleoclimatic evidence. Evidence of past climates, such as glacial deposits in now tropical regions, supports the idea that continents have moved across different climatic zones over time. This indicates significant shifts in the positions of continents relative to the poles.
If you're a young scientist, then you need to know how fossils proved continental drift. Ready for a time-traveling adventure? Alfred Wegener had a wild idea: all the continents were once connected. He called it continental drift. But how did he prove it? Fossils were the key. Wegener didn't find the fossils himself, but he spotlighted scientific documents showing the same species fossils on different continents. Imagine finding identical plant fossils in South America and Africa, or dinosaur fossils in both India and Antarctica. These weren't just coincidences. They were clues that these lands were once joined. Wegener's theory was bold but spot on. Thanks to fossils, we now know our planet's history is a lot more connected than we ever thought. Isn't science amazing? None of this looks random, right? There's actual science that explains how continents fit together. Believe it or not, the coastlines of South America and West Africa seem to match up perfectly. But the real kicker, their rock terrains do too. Check this out. The Appalachian Mountains in North America are linked with the Scottish Highlands. And the rock layers in South Africa's Karoo system, they match up with Brazil's Santa Catarina system. Even more amazing, glaciers carve rocks and leave marks as they move. Scientists use these clues to figure out how continents have shifted over time. Plus, coal deposits in Antarctica suggest it was once warm enough to support plants and tall trees. Imagine that. During Pangea time, continents were on the move. Check out the arrows showing their direction.
It shows how Alfred Wegener mapped out the distributions of the four Permian and Triassic fossil groups and used it as biogeographic evidence for continental drift. This is why you need to know about Cynognathus. It's a reptile that roamed like a wolf. Meet Cynognathus, a fascinating relic from the Triassic period, about 250 million years ago. This ancient beast was no ordinary reptile. It had mammal-like features and was roughly the size of a wolf. How cool is that? Cynognathus fossils have been unearthed in South Africa and South America, but here's a twist. These regions were once connected, forming a supercontinent called Pangea. This means Cynognathus never needed to swim across the Atlantic because it didn't exist yet. As a dominant land species, Cynognathus was a top predator of its time, ruling the terrains with its sharp teeth and powerful jaws. Imagine spotting one of these in your backyard. So next time you think of ancient creatures, remember Cynognathus, the wolf-like reptile that once roamed Pangea. Paleontology rocks, doesn't it? Ready for a prehistoric puzzle? Let's unravel why the Mesosaurus stayed close to home. Meet the Mesosaurus. This early Permian period reptile, a distant relative of modern crocodiles, swam through waters with its long hind legs and limber tail, but here's the kicker. Its fossils are only found in South Africa and eastern South America, so why didn't it cross the Atlantic? Simple, the Mesosaurus was a coastal creature not built for long oceanic journeys. Back then, South America and Africa were part of a supercontinent called Gondwana. No vast Atlantic stood in its way, it was all connected land and shallow seas. Imagine this. As the continents drifted apart over millions of years, the Atlantic Ocean grew to its current size. By then, the Mesosaurus had long been extinct, so it never faced the challenge of an ocean crossing. Next time you think about continental drift, remember the Mesosaurus. This little reptile is a fascinating piece of Earth's geological puzzle. You need to watch this if you struggle with imagining ancient creatures. Let me introduce you to Lystrosaurus. Lystrosaurus, or shovel reptile, was a fascinating herbivore with a stout body reminiscent of a pig. Picture a dinosaur with a pig-like build, munching on plants millions of years ago. What's even more intriguing is where we find Lystrosaurus fossils only in Antarctica, India, and South Africa. This distribution tells us an incredible story about ancient continental drift. These creatures couldn't swim across oceans, so their presence in these regions suggests these lands were once connected. Lystrosaurus shared its world with another land dweller, Cynognathus, but it had a unique charm of its own. Its tusks and beak-like mouth made it a distinctive character in the prehistoric world. So, next time you think of dinosaurs, remember the pig-like shovel reptile Lystrosaurus. What I wish I knew in middle school instead of high school is how a plant fossil could change our understanding of the world. Meet Glossopteris, the fossil rock star that's got scientists buzzing. Found in Australia, Antarctica, India, South Africa, and South America, this plant is like the ultimate world traveler. But wait, it couldn't fly or drift. Its seeds were too big and bulky to cross oceans. So how did it end up on all these continents? Drum roll, please. Continental drift. This means that all these southern continents were once connected, forming a supercontinent called Gondwana. Glossopteris is more than just an ancient plant, it's a key player in proving that our continents were once cozy neighbors. So next time you think of fossils, remember Glossopteris, the little plant that made a big splash in the world of geology?